Hello everyone. In this video, we are going to learn the atomic foundation of matter for grade 9, CBSE 9 as well as state 9 according to the new syllabus of 2026-27. So what are the key concepts we are going to cover? First one, law of conservation of mass. Second one, law of constant proportion. Third one, Dalton's atomic theory. Next we will learn how atoms combine, that is concepts of covalent bond and ionic bond. Next, we learn about the symbols and valencies, okay, concepts of the ions, how ions are formed, cations and anions, okay, and how to write a chemical formula, okay, and how to find the molecular mass. These are the key concepts we are going to learn. At the end, we will summarize the chapters. We will also learn the difference between the ionic compound and covalent compound. So please watch the video till the end. You will understand each and every concepts. First, when we talk about law of conservation of mass, what is law of conservation of mass? According to this law, masses can neither be created nor be destroyed. This was given by Lavoisier in the year 1789. Or we can say that during a chemical reaction, masses of reactant is always equal to the masses of product. Okay, so you can see one equation I have taken. Carbon plus oxygen gives rise to carbon dioxide. The substances which combine, okay, so left hand side of this arrow mark, they are called as reactant. Okay, right hand side is what? A product. So carbon plus oxygen gives you carbon dioxide. What is the symbol of carbon? C. Oxygen O2, carbon dioxide CO2. So here carbon 12 gram, when it combined with 32 gram of oxygen, it gives 44 gram of carbon dioxide. So if you see masses of reactant, that is 12 plus 32 will get 44 gram, and masses of product also 44. So we can say that during a chemical reactions, masses of reactant is equal to masses of product. Okay, this is only called as law of conservation of mass. We can see the statement. This law states that mass can neither be created nor be destroyed. Or, according to this law, during a chemical reactions, masses of a reactant is always equal to the masses of product. Am I clear? Next, concepts we talk about the law of constant proportion, also called as law of definite proportion. Okay, first see the statement. According to this law, a chemical compound always contains its constituent elements in a fixed mass ratio. What does this mean? Okay, consider water. Okay, when we talk about water, water is made up of 2 atoms of hydrogen and 1 atom of oxygen. Yes or no? So when we talk about the ratio of masses of hydrogen and oxygen, so what is atomic mass of hydrogen? 1 U. Okay, atomic mass of oxygen is what? 16 U. So when we take the ratio of masses of hydrogen to the mass of oxygen, at hydrogen 2 atoms are there, so 2 into 1, by oxygen 1 atom is there, so 1 into 16. So 2 by 16, so 2 1 are 2, 2 8 are. So ratio is 1 is to 8. By whatever method you form the water, the ratio of mass of hydrogen and oxygen is always going to be fixed, that is 1 is to 8. This is only called as law of definite proportion, a law of constant proportion. Am I clear? Next, we talk about this question also asks for 2 to 3 marks. Dalton's atomic theory. Okay, John Dalton in the year 1808 he gave a Dalton atomic theory. What he told, first try to understand. Okay, what he told, all the matters are made up of very tiny particles called as atoms. Okay, atoms are indivisible, means we cannot divide the atoms. They are indivisible. He also told that atoms of a given element are identical in masses and chemical properties. Okay, atoms of different elements are different in masses and chemical properties, and he also told that atoms of the elements combine in a simple ratio to form a compound. Okay, so you can see the statement. First statement, the all matter is made up of very tiny individual particles called atom which participate in a chemical reaction. Second one, atoms are individual particles which can not be created or destroyed in a chemical reaction. Third one, atoms of a given element are identical in masses and chemical properties. Next, atoms of different element have different masses and chemical properties. Next, atoms combine in the ratio of simple whole number to form compounds. Okay, now an atom always contains the same element. sorry, compound always contains the same element, like water. Water always contains 2 atoms of hydrogen and 1 atom of oxygen. Am I clear? Now, I'm going to cover, few important concepts related to the atom that you should understand. What do you mean by atom? So, atom is nothing but the smallest particle of the matter which does not exist independently. Am I clear? So, what is matter? Anything which occupies a space and has mass is called as matter. So, matter is basically 3 types: solid, liquid, and gases. Okay, so here I have also explained in this slides you see about the matter. Just you should know, anything which occupies a space, has a mass, and is perceived by our senses is called as matter. For example, this pen, book, table, air. So they are what are matters. Characteristics of matter means matters are made up of very small particles generally. These may be atoms, ions, or molecules. The particles of matter have a space between them, that is called as intermolecular distance. The particles of matters are attracted, with a force, that is called as intermolecular force of attraction, and particles of matters are continuously moving in random motion. These are the few characteristics which you should know. Okay, so I have mentioned here, you can go through. Characteristics of matter, important. Now coming to the concepts of atom, ions. So as I told you, atom is nothing but the smallest particle of the matter which does not exist independently. Okay, what is a molecule? A molecule is a group of atoms which exist independently, like oxygen, O2, Cl2, CO2. So, based on the atoms, molecules are classified into 2 types: homoatomic molecule and heteroatomic molecules. If the number of atoms in a molecule is same, it is called as homoatomic. For example, oxygen made up of 2 atoms of oxygen. Okay, chlorine made up of 2 atoms. Heteroatomic molecule is if the atoms present in a molecule is different, like a CO2, carbon dioxide, ammonia, NH3, okay, CH4, methane. Okay. Next concepts we talk about atomicity. What is atomicity? It is the number of atoms present in a molecule of a compound. Okay, so based on the atomicity, we can classify molecule as monoatomic, diatomic, triatomic. If number of atoms in a molecule is 1, it is called as monoatomic. If it is 2, it is called as diatomic. Okay, here I have made one table that you can see. Atomicity is 1, called as monoatomic. Example, all noble gases: helium, neon, argon, krypton, xenon, radon. If the atomicity is 2, it is diatomic, like oxygen, chlorine, nitrogen, fluorine. If that atomicity is 3, means it has 3 atoms, it is called as triatomic, like O3, ozone, CO2, carbon dioxide. If atomicity is 4, it is called as tetraatomic or polyatomic also you can say, like P4, NH3, ammonia. If it is 8, like polyatomic, sulfur acid. Am I clear? So basically atoms, what happens, atoms has 2 main part. One part is nucleus, second part is orbit or shell. What is the nucleus? Nucleus is nothing but central part of the atom which contains protons and neutrons. And electrons are revolving around the nucleus in circular path, that is called as orbit or shell. That you should know. Okay, few concepts of next chapter, that is the structure of atom, we have also covered in this. So here subatomic particle like E is nothing but electron, the charge is negative. What is the value of charge? Minus 1.6 into 10 to the power minus 19 coulomb. Mass is 9.1 into 10 to the power minus 31 kg. P for protons, positive charge. Okay, the charge value is how much? 1.6 into 10 to the power minus 19 coulomb. And the mass value is approximately 1.6 into 10 to the power minus 27 kg. N for neutron, which is neutral, value is 0. The mass is nothing but 1.676 into 10 to the power minus 27 kg. This is approx value. Okay, you should also know about the atomic number. When we talk about atomic number, it is nothing but the number of protons present inside the nucleus of an atom, or number of electrons present outside the nucleus of a neutral atom. So we can represent atomic number as Z here, is nothing but number of protons, or for a neutral atom, number of protons or number of electrons. Am I clear? What do you mean by mass number? Mass number is generally represented as a, it is nothing but the sum of protons and neutrons present inside the nucleus of an atom. So A is equal to what? P plus N. The number of protons plus number of neutron is mass number. For any atom X, we are representing atomic number and mass number like this. Atomic number we are writing on the bottom side, left side, and mass number upside. For example, carbon 6 and 12. 6 is atomic number, 12 is the mass number. Nitrogen 7 and 14. Oxygen 8 and 16. So Z is atomic number, A is the mass number. How do we find the number of neutron? Since we know that mass number is what? P plus N. Atomic number is what? P. So P plus N minus P get cancelled. Okay, so we will get the number of neutron is what? A minus Z. Number of neutron is what? Mass number minus atomic number. Yes or no? So number of neutron is nothing but a mass number minus atomic number. Next we talk about electronic configuration. What do you mean by electronic configuration? The arrangement of electrons in the orbit is called as electronic configuration. Okay. So it is following one rule called as 2n square rule. What is this rule? According to this rule, the maximum number of electron which is present in an atom is given by 2n square. Okay. So n is equal to 1, it is called as K shell. 2 into 1 square, that is 2 electrons. For n is equal to 2, that is L shell. 2 into 2 square, that is 8 electrons. N is equal to 3, that is M shell. 2 into 3 square, that is 18 electrons. N is equal to 4, that is N shell. 2 into 4 square, that is 32 electrons. So this rule was given by 4 only. Am I clear? Now you should also know a stability rule. Okay, there are two rules. One is duplet rule, other is octet rule. Okay, octet rule states that if the valence electron of the atom is 8, then it is stable. Valence electron means last shell electron. Okay, for example, okay, when you talk about neon, atomic number is 10. So according to the electronic configuration rule, K shell, L shell, M shell, first shell will have 2 electrons, next shell 10 minus 2, that is 8 electrons. It is stable. Neon is stable. Argon, atomic number is 18. So 2, 8, 8. First shell will have 2 electrons. Yes, we will give. Next shell 8 electrons. Third shell can have maximum 18 electrons. If 18 is not there, we can give 8 or less than 8. So 2 plus 8, 10. So 18 minus 10, how much are 8? So it will be there in the last shell. So valence electron is 8. That's why it is stable. Am I clear? Duplet rule. Duplet rule states that if the valence electron of the atom is 2, then it is stable. So this is the orbit for helium and helium-like particle like lithium. Helium atomic number is 2, so valence electron is 2. First shell only 2 electrons. That is a valence shell. Electron is 2. Am I clear? So this is the octet rule and duplet rule. So no? Okay. What is ions? These are the charged species. Okay, charged species are called as ions. It is basically two types: cations and anions. Cations are nothing but positively charged ions, which are formed by the loss of electrons. Okay, how they are formed? Try to understand. Sodium, atomic number of sodium is what? 11. Electronic configuration 2, 8, 1. Yes or no? So what happens to become stable? It has two ways: either to lose one electron or gain 7 electron. Which one is easier? Losing one electron is easier. So it loses one electron, become Na plus. So 2, 8. Am I clear? So as it has 11 protons, 11 electrons, there is no charge. Okay, after losing one electron, becomes 2, 8. So electron number is 10, proton number is 11. As it has one extra proton, to show the presence of extra proton, we are writing Na plus. Am I clear? Similarly, if you see magnesium, atomic number is 12, 2, 8, 2 is the electronic configuration. To become stable, it loses 2 electron, become Mg2 plus. Aluminium 2, 8, 3. To become stable, it loses 3 electron, becomes 2, 8, L3 plus. Same, 13 protons, 10 electrons. Am I clear? What do you mean by anions? Anions are nothing but negatively charged ions. How they are formed? By the gain of electrons. Like chlorine, atomic number is 17, 2, 8, 7. Yes or no? To become stable, it gains 1 electron, becomes Cl minus ion, 2, 8, 8. In this way, cations and anions are formed. Okay, oxygen, atomic number is 8. So 2, 6. To become stable, it gains 2 electron, become O2 minus ion. Nitrogen, atomic number is 7. So 2, 5. To become stable, it gains 3 electrons, become N3 minus. Am I clear? So this is the way how cations and anions are formed. So you have to remember one concept, sir. If the valence electron of the atom is 1, 2, 3, so generally it belongs to metal and their valencies are 1, 2, 3 respectively. Okay. So generally they will lose a 1, 2 and 3 electrons to become stable. So they are generally metals. They will form cations. And if the valence electron of the atom is 5, 6 and 7, generally they belong to non-metal. And to become stable, they will gain electrons. Make clear? So what is valency? The combining capacity of an atom is called as valency. It is generally calculated by the number of electrons lost by the atom or gained by the atom. Okay. So here these 2 points are very, very important. So if the valence electron is 5, 6, 7, how do you find the valency? 8 minus valence electron will be the valency. And if the valence electron is 1, 2, 3, how do you find the valency? Valence electron is the valency. You can see what is valency. The combining capacity of an atom is called as valency. Okay, so it is generally calculated by the number of electron lost or gained during a chemical bonding. Here, these are to write correct chemical formula. You should know the symbols. How do you write the symbols and what is their valency, which is very, very important. Okay, you can score 2 to 3 marks. Okay, if you know proper chemical formula with their valencies. Chemical are like name of the atom and their valency. Here, name of the ions are there, their formula and valencies. Sodium Na plus 1, lithium Li plus 1, potassium K plus 1, silver Ag plus 1, calcium Ca2 plus 2 is the valency, barium Ba2 plus 2. Am I clear? So these are the cations actually. Here iron is having variable valency. Less valency is called as like a ferrous and Fe2 plus valency is 2, and more valency is a ferric we are using. So ferric Fe3 plus. So 3 is the valency. Similarly, copper, cuprous and cupric. Cuprous is what? Plus 1, that is 1 valence, and cupric is plus 2, that is 2 valence. Magnesium, Mg2 plus, so 2 is the valency. Zinc, Zn2 plus, 2 is the valency. Aluminium, Al3 plus, 3 is the valency. So these are the cations. Now coming to the anions, fluoride, so F minus, 1 is the valency. Chloride, Cl minus, 1 is the valency. Bromide, Br minus 1, so 1 is the valency. Iodide, I minus, 1 is the valency. Oxide, O2 minus, 2 is the valency. Sulfide, S2 minus, so 2 is the valency. Apart from these two, you should remember the polyatomic ions also, like a hydroxide, OH minus, 1 is the valency. Nitrate, NO3 minus, 1 is the valency. Hydrogen carbonate, also called as bicarbonate, so HCO3 minus, 1 is the valency. Carbonate, CO3 2 minus, 2 is the valency. Sulfate, SO4 2 minus, 2 is the valency. Ammonium, NH4 plus, so 1 is the valency. Am I clear? Now, how atoms combine? Okay, one concepts they have added in this academic year, how atoms combine, and finally we'll learn the chemical formula also. Atoms combine by two ways, either ionic compound, ionic bond, or covalent bond. Covalent bond and ionic bond. So when we talk about covalent bond, it is a type of chemical bond which is formed by the mutual sharing of electrons. Okay, how covalent bond is formed? By mutual sharing of electrons. Try to understand. Okay, for example, see hydrogen H2, Cl2, O2, N2. Okay, hydrogen, atomic number of hydrogen is what? 1. Electronic configuration 1. Hydrogen, you can see one valence electron is there. Electron can be represented as dot or cross. That you remember. So to become stable, it will take 1 electron. By duplicate rule, it is stable right now. So valence electron is 2, it is stable. So as one pair of electron is here, it is what? Single bond. Am I clear? Now coming to the O2. Oxygen, you see here, atomic number is what? 8. So electronic configuration 2, 6. Am I clear? So oxygen is having 6 valence electron. 1, 2, 3, 4, 5, 6. Here also see 1, 2, 3, 4, 5, 6. To become stable, what will do? It will take a 6 plus 2, 8 electrons. Similarly, it has 6, it will take 2, 6 plus 2, 8 electrons. As 2 pair of electrons is here, that's why it is what? A double bond. Similarly, we can see chlorine, Cl2. Chlorine atomic number is what? 17. Atomic number is what? 17. So electronic configuration 2, 8, 7. So you can see here 1, 2, 3, 4, 5, 6, 7. Here also another atom 1, 2, 3, 4, 5, 6, 7. To become stable, what it will do? It will take one electron become stable by octet rule. Here also between chlorine, one atom is one electron pair is there. So it is what? A single covalent bond. Am I clear? Now we talk about ionic bond. What is ionic bond? The type of chemical bond which is formed by the transfer of electrons. Okay. For example, NaCl. See, sodium, as you know, sodium atomic number is what? 11, right now. So electronic configuration 2, 8, 1. To become stable, it loses one electron, become what? Na plus ion 2, 8. Similarly, you see chlorine atomic number is what? 17. Electronic configuration 2, 8, 7. To become stable, okay, that is octet rule, it will gain one electron. Form Cl minus 2, 8, 8. So what we can see, sodium needs to lose one electron, chlorine needs to gain one electron. So we can see sodium is losing, or sorry, transferring one electron to chlorine atom. So sodium forms Na plus and chlorine forms Cl minus ion. So this is the dot structure given by the Lewis, also called as Lewis dot structure. So sodium, which is having one valence electron, chlorine, which is having 1, 2, 3, 4, 5, 6, 7 valence electron. Sodium is transferring one electron. So sodium form Na plus and chlorine form Cl minus ion with having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. As you know that unlike charges attract each other, yes or no? So Na plus and Cl minus will form what? NaCl. In this way, ionic compounds are having high melting and boiling point. That you have to remember. Covalent compounds are having low melting and boiling points. Ionic compounds are generally soluble in water. Covalent compounds are generally insoluble in water. Ionic compounds are formed by the transfer of electron, whereas covalent compounds are formed by the mutual sharing of electrons. Okay, if you see petrol, kerosene, diesel, all are covalent compounds. NaCl, common salt, that is a NaCl is common salt, okay, which is a ionic compound. Am I clear? Next we talk about how to write the chemical formula. So covalent compound may be also there, ionic compound may be there. First we will talk about the covalent compound, hydrogen sulfide. How we are writing the first writing the symbol. Hydrogen symbol is H, sulfide symbol is S. Well, below that we are writing the valency. Hydrogen valency is 1, sulfur valency is, sulfide valency is 2, and crisscross method. 2 will move here, 1 will go here. So H2S. Next, carbon tetrachloride, CCl. Carbon is what? 4, valency, chlorine is 1. So 1 will move here, 4 will move here. So CCl4. Hydrogen chloride, hydrogen H, chloride Cl. Valency 1, valency 1. So 1, 1 will go. 1 generally we are not writing, so HCl. Am I clear? Ionic compound. So calcium chloride. First we are writing the symbol Ca, chlorine, Cl. Chloride is what? Cl. Below we are writing the charge. Plus 2 charge and minus 1 charge. So 2 will move here, 1 will move here. So CaCl. Aluminium oxide. Aluminium Al, oxygen O. Valency is aluminium 3 plus, oxygen 2 minus. So 3 will move here, 1 will move here. Crisscross method only. So Al2O3. Magnesium oxide. Magnesium Mg, oxygen O. Oxide. Okay now. Magnesium, you see here, magnesium, okay, charge is what? Plus 2. And oxygen also charge is minus 2. So plus 2 minus 2 get cancelled. So 1 will get. Okay now, if it is same, we can cancel. So 1 we are generally not writing. So Mg1, O1. So MgO. Am I clear? How to find the molecular mass? Molecular mass is nothing but the sum of atomic masses of the various elements present in a molecule of a compound. Okay, so you should remember the atomic masses of various elements like hydrogen is 1, carbon is 12, oxygen is 16, U is for the atomic mass unit, sulfur is 32, nitrogen is 14. So I want to find for water. Okay, so first you try to understand. How do you find? So water, you see, hydrogen, how many atoms are there? So 2 into its atomic mass of hydrogen. Okay, now atomic mass of hydrogen is 1. Oxygen 1 atom is there, so 1 into atomic mass is 16. So 2 plus 16, how much? 18U. Similarly, H2SO4, sulfuric acid. So hydrogen is 2 atom into atomic mass is 1, plus sulfur is 1 atom into atomic mass is 32. Oxygen is 4 atom into atomic mass, that is 16. Okay now. So 2 plus 32 plus 64. You get 98 U. Am I clear? Similarly, CO2. Carbon is 1 atom into 12 plus oxygen 2 atom into 16. So 12 plus 32, that is 44. Okay, U is what? Atomic mass unit. In this way, we are finding the molecular mass. Let's take one more. Glucose you take. Glucose is what? C6H12O6. So carbon 6 atom is there, so 6 into atomic mass of carbon, that is 12, plus hydrogen 12 atom is there into atomic mass, that is 1. Oxygen 6 atom is there into atomic mass, that is 16. So 72 plus 12 plus 96. If you solve this, you will get a 180. I hope you understood all the concepts okay, related to this chapter, which is chapter number 10, Atomic Foundation of Matter, according to the new syllabus of CBSE for the academic session 2026-27. Okay, please like the videos, share with your friends, and don't forget to subscribe the channel. Thank you.